This is a video on how to find the empirical formula of a compound and then how to also find the molecular formula of a compound. So in this example, they give me the percent nitrogen and the percent oxygen in the compound, and they give me the molar mass. They only give me the molar mass if I'm finding the molecular formula. That's another step, so I'm going to totally ignore that number for now. The first thing I'm going to do is find the empirical formula. So my first step is to transfer the percent simply into grams. So 30.45% nitrogen equals 30.45 grams of nitrogen and 69.55 grams of oxygen. This is because if I assume I have 100 grams, 30.45% of that will be 30.45 grams. Now I t-chart both of these to find the number of moles. So I'm going to use 14.01 as the molar mass of nitrogen. Now I'm using my same t-chart rules where I drop the units that I have down and I want moles, so those units come up. I'm going to do the same thing with oxygen. The molar mass of oxygen is 16 and it's 1 mole. Well, actually 16.00. So when I do that, let's see, get out your calculator. I'm going to type in 30.45 times 1 divided by 14.01, and I get 2.173, so it's 2.17 moles of nitrogen. Keep that moles of nitrogen. It's really important we don't mix up our different chemicals here. Then 69.55 grams of oxygen times 1 divided by 16.00, and I get 4.346, so that's going to be 4.35 moles of oxygen. Now we divide by the smallest number. Well, looking at both of these, 2.17 is smaller than 4.35, so I'm going to divide each by 2.17. Obviously, 2.17 divided by 2.17 is a 1, so I have 1 nitrogen. Now 4.35 divided by 2.17 equals 2.003, so I'm rounding that to 2 oxygens. That means that my formula has 1 N and 2 O, so NO2. When I write the formula, I write it based on the order they gave me the compounds in. That is simply finding the empirical formula. That was step 1 of the problem. Now I need to look at step 2, which asks me to find the molecular formula. That's when I use the molar mass. What it means is I have this substance with subscripts for this NO2. And it's some substance, and that substance has a molar mass of 138.03 grams per mole. This substance, when it's reduced, turns into NO2. What that means is I could have NO2, I could have N2O4, I could have N3O6, and it just keeps going and going, N4O8. All of these, when they're reduced to their empirical formula, will be NO2. So I have to figure out which one it is. So I need to find out the molar mass of NO2 so I can convert it back the same way. So if I add up an N, which is 14.01, and 2 O's each at 16.00, I get 46.01 grams per mole. Now I have to look at my calculator and figure out how do I get from 46.01 to 138.03. So I'm going to do 138.03 divided by 46.01, and I get 3. That means I have to multiply the empirical molar mass by 3 to get the molar mass of the molecular compound. That also means that the empirical formula needs to be multiplied by 3 to get the molecular formula. So here I have 1 N, now I'm going to have 3 N's. Here I have 2 O's, now I'm going to have 6 O's. And this is the molecular formula, while NO2 is the empirical formula. It is possible for both the empirical and the molecular formula to be the same. If instead when I had done this, I told you that the molar mass of the compound was 46.01, we would have figured out that the empirical formula was also the molecular formula.